Hello students, in the previous lecture we have solved problem to obtain obliques asymptote of an rational algebraic curve. Now in this third lecture on asymptotes, we'll again solve problem based on asymptote of an rational algebraic curve of the type f of x y equals 2. Now, the first problem is find all the asymptotes to the curve y cube minus 3x square y plus xy square minus 3x cube plus 2y square plus 2xy plus 4x plus 5y plus 6 equals 0. The solution is the given equation is the equation of the first equation is the equation of the rational algebraic curve. Now, in order to find rectangular asymptotes, put the coefficient of highest power of x is equal to highest to highest is equal to 0, but the coefficient of highest power x is minus 3, which can't be equal to 0. Therefore we don't have any asymptote which is parallel to x is equal to 0 is parallel to x-axis. Similarly, to find the vertical asymptote, put the coefficient of highest power of y is equal to 0. So the highest power of coefficient of highest power of y is equal to 1 can't be 0. Therefore we don't have any vertical asymptote. So now this rational algebraic curve does not have rectangular asymptotes. Now our aim is to find the oblique asymptotes. Now this is a third degree. This third degree rational algebraic curve. These are third degree terms. This will give us phi 3. If we in the third degree term, if we put x equal to 1 and y is equal to m, we'll get phi 3m. And if it is in the second degree terms, we put x is equal to 1 and y is equal to m, we get phi 2m. In the first term, we put x is equal to 1 and y is equal to m, is equal to the first term. If in the constant term, phi not m is equal to 6. So this. Now to obtain oblique asymptotes, oblique asymptote type y is equal to mx plus c. We put x equal to 1 and y is equal to m in equation in different degree terms of the equation, rational algebraic equation first. So if you put in the third degree term, if in the third degree of the phi of xy, if you put x equal to 1 and y is equal to m in the third degree term of the phi of xy is equal to 0, we'll get phi 3m. And if you put x is equal to 1 and y is equal to m in the second terms of the phi of xy, we get phi 2m. Similarly, if put x is equal to 1 and y is equal to m in the first degree terms of the phi of xy, this is the first term. Now differentiate phi 3m with 2x. Phi 3m dash is equal to 3m square minus 3 minus 3m. Cm square minus 2m minus 3 minus 2 plus 2 minus 3. Now this. Now in order to find the slopes, now to find the values of m, the slopes of the oblique asymptotes, we'll solve the equation phi 3m for different values of m. This cubic in m will get 3. We'll search for the real roots of this phi 3m. We'll factorize it. Factorize after solution, we got m is equal to minus 1 plus minus under root 3. So they are all three real roots. So this equation, this phi of xy will have at most will have 3 or 3 will give us the 3 slopes of 3 asymptotes. So this will have 3 so or at most, because this is third degree, it will have at most 3 asymptotes. None of the roots of this equation is repeated. So the value of c will be given by phi minus of phi 2m upon phi 3 dash m. I can substitute the value of phi 2m and phi 3 phi 2m and phi 3 dash m here. Now for m is equal to minus 1, phi is equal to minus 1, c will be equal to put m is equal to minus 1 here. We got 0, 0. The corresponding asymptote is equal to y is equal to minus x plus 0. For m is equal to under root 3, c will begin by put m is equal to under root 3 in this equation. After solution, m is equal to 3 in this equation. So after solution, we got the value c is equal to minus 1. So asymptote will be asymptote will be y is equal to under root 3 under root 3 under root 3 x minus 1. Now for x is equal to minus under root 3, so find the value of c again from the same formula. Put x is equal to minus under root 3. Put m is equal to minus under root 3 and solve it. We got c is equal to minus 1. The question is asymptote will be y is equal to minus under root 3 x plus minus 1. These are the three asymptotes of the rational algebraic curve given by Joseph first. Now let's solve another problem. Find all the asymptotes through the curve x cube minus x square y minus xy square plus y cube plus 2x square minus 4y square plus 2xy plus x plus y minus 1. Now this rational algebraic curve is a third degree. So it means from this we can guess that this equation will have at most three asymptotes. So let us first find the does this equation have these rectangular asymptotes? So to find a horizontal asymptote, put the coefficient of highest degree of x is equal to highest degree of x is equal to 1. 1 can't be 0. So the equation does not have which is constant, which can't be 0. Therefore, this equation have no vertical asymptote. No vertical asymptotes. Similarly, put the coefficient of uh, no horizontal asymptote. Sorry. Because actually no horizontal asymptote. Put the coefficient of highest power of x equal to 0. So it is constant. Constant can't be 0. So this equation, this rational graph have no horizontal asymptote. Similarly, put the coefficient of highest power of y, which is 1. 1 can't be 0. Therefore, this equation have no vertical asymptote. So this is this equation. This is rational algebraic curve does not have any rectangular asymptote. So let's search for the oblique asymptotes. Oblique asymptotes. So let y equal to mx plus c is an oblique asymptote to the curve given first. So in order to find the value of m and c, we'll put x to 1 and y is equal to m in the different degree terms of the phi of xy. So if we'll put the m is equal to x equal to 1, y equal to m in the third degree term of the phi of xy, sorry f of xy, then we'll get phi 3m is equal to 1 minus m minus m square plus m cube. Yes. The definition of this will be equal to definition is equal to minus 1 minus 2m plus m square. Second derivative of this phi 3m is equal to 0 minus 2 6m. And similarly phi 2m will equal to, if you put x is equal to 1 and y is equal to m in the secondary term of this question. Secondary term, these are secondary term. 2 minus 2m square plus 2m. 2 minus plus 2m minus 4m square. 4m square plus 2m. Right. This, if we differentiate this, we'll get 0 to minus 8m. Now phi 1m is equal to first term m x equal to 1 and y equal to 1. 5m and phi not m equal. Now to find the differential m, we'll put the phi 3m is equal to 0 and solve it for real roots. 1 minus m minus m square minus 2 minus m cube. Factorize it. 1 minus m minus m square. 1 minus m, 1 minus m. So m is equal to minus m equal to 1 plus minus 1. So these are the m differential slopes over m are minus 1, 1. Minus 1, 1 are repeated root. 1 is repeated root. To find the value of c for repeated root, the formula will be used c square root factorial phi 3 second derivative of m is to m plus c second derivative of phi 2m is to m plus phi 1 m is equal to 0. Now for m is equal to 1, put m is equal to 1 in, put phi value and m is equal to 1 in c square by 2 phi in phi 3 third derivative m, put m is equal to 1. Phi second derivative of phi 2, third derivative phi 3, second derivative phi 2m, phi 3m, second derivative phi 2m, and finally put the value m is equal to 1. And we'll get a quadratic equation in C, then solve for two values of C. So we'll get two asymptotes parallel to slope m equal to 1. Similarly, for m equal to 1, the value of C will be given by C is equal to minus phi 2m upon phi 3 derivative raised to m. This is equal to, again, substitute the values and put m is equal to -1, and we'll get the value, find the value of c, put the value of c in the y is equal to mx plus c, m and c in this, and we'll get the, this is the corresponding asymptote to the slope, and equal to -1. Now find all the asymptote to this curve. Y cube plus x square y plus 2xy square minus y plus 1 equals 0. Again, this is cubic. This rational geometric curve is cubic in cubic. So let's find the rectangular asymptotes. Highest coefficient of y is 1. 1 can't be 0. So no, 1 can't be 0. So this implies no for vertical asymptotes. This rational curve have no vertical asymptote. So the highest coefficient of x is x square. Put the coefficient, this is y equals 0. Y equals 0 will act as a y axis will act as a horizontal asymptote. Y equals 0. Coefficient x. Y equals 0. X axis will act as a horizontal asymptote. No vertical asymptote, and this is a horizontal asymptote. X axis will act as a horizontal asymptote. The coefficient of highest power of y, no vertical. So this equation have one asymptote. Now to obtain the same procedure adopted to obtain the oblique asymptote, put x equal 1 and y equal I mean the in equation different degree terms of equation. First we'll get put y equal to x equal 1 and y equal to m in the third degree term, we get 5m. And if you put the x equal to 1, y equal second term, this is 0. Put x equal to 1 and y is equal to m in the first term, 5 1 m equal to -1. And differentiate this with x and second with x. So to 5 3m, second with 5 2m with m, and then 5 m dash into and 5 m dash into and 5 m. To find possible slopes of oblique asymptotes, put 5 km equal to 0 and solve this for real roots. So 5 km is equal to m is common, m square plus 2m plus 1, m plus 1 whole square. So m is equal to 0 and -1 are the three slopes. So now we'll find the intercept for different slopes of the asymptotes because they are real. M is equal to 0, then c comes to 0. This implies y equal to 0. This is the horizontal asymptote which we calculated in the case of the same asymptote. If for repeated root m is -1, we get two values of c means we get two asymptotes parallel to slope m is equal to -1. C given away, there is c given c square root factorial phi 3 m double derivative plus c phi 2 m dash the first derivative plus phi 1 m is equal to 0. Put the value of m is equal to 1 phi 3 dash. We can substitute the value of this phi m dash phi 2 dash m and phi 1 dash m. Put m is equal to -1 in this. Put the value and simplify them. We get a quadratic in c. Solve for c plus -1. So we got two simple here. One is y equal to 0 and y equal to -x m. 1 plus 1 y equal to 3 simple. And is equal to this, there is equal the curve at most 3. So no other simple here. Now let us solve fourth degree rational algebraic curve for the asymptotes. Find all the asymptotes to the curve x of 4 minus 2x cube y plus 2xy square minus y equal to 4. This is 4 degree term of f of xy plus x cube minus 4x square y plus 5xy square plus 2y cube. This is third degree term plus x square minus 3xy plus 2y square the second term, and first term is missing there, and this constant term is missing. Find all the asymptotes of this rational algebraic curve. To find rectangular asymptotes, let's find the horizontal. So put the coefficient of highest power of x, that is x of 4, which is 1. 1 can't be 0, so we don't have any horizontal asymptotes. Put the coefficient highest power of y is equal to 0, but the highest coefficient of y is -1. -1 can't be 0, so no vertical asymptotes. So now this rational algebraic curve have no rectangular asymptotes. That is, it has no horizontal as well as vertical asymptote. So Now this is a rational geometry of degree 4, so it will have at the most four asymptotes. So let us find the oblique asymptotes. So in order to find oblique asymptotes, uh, let y is equal to x plus c. Y is equal to x plus c, then oblique asymptote this curve. Now in order to find the value of m and c, we'll put x equal to 1 and y is equal to m in different terms of phi of xy, and we will get new functions phi 4. And if you put x 1 and y is equal to m in the fourth degree term, we get phi 4m. You put x equal to 1, y equal to m in the third term, we put phi 3m. If x equal to 1, y equal to m in third second term, we put phi 2m and phi 1m first term and phi is a constant term. Now, in order to find because the slopes are given, if you solve the phi 4m highest degree term, if you get highest degree term 0, 0, 0 and solve it for real values, but this is a 4 degree term, 4 degree polynomial equation. In m we can't solve it, so we have to use the hidden trial method to find the two roots, and then with the help of harder methods and division we can find the other roots. So what is the trial method? In phi m4, to find m, phi m4 is this 4 degree, we can't factorize it. Factorize, we take this common, we can't get it in common. So we have to use trial method. We'll put m equal to 1, m equal to 1. We'll search for two roots or two zeros, two roots of phi 4x, phi 4m, and or two zeros of phi 4m or two roots of phi 4m is equal to 0 by trial method. M equal to 0, 1, minus 1, 2, minus 2, and so on. So we put m is equal to 0, 5, 4, 0 is comes out to 1, 1 comes 0. So 0 is not a root of this 5, 4m equal to 0. Okay, m is equal to 1, 5, 4m is equal to comes out to 0. 1 is a root of 5, 4m equal to 0. Or 1 is 0, 5, 4m. So 1 is the root of the 5, 4m. Now again put m is equal to minus 1. 5, 4m minus 1 is equal to come to 0. Minus 1 is a root of 5, 4m equal to 0 or 0, 5, 4m. Now we got two roots. So we can, if you have a harness, if you play harness method two times, and then then the quotient will come down to quality equation, we can solve that. Now we're factorizing into the fourth polynomial into two. One factor will give me m is equal to minus 1 factor, so m minus 1, m is equal to 1 is the root of 5, 4m, therefore m minus 1 is factor of 5, 4m. M is equal to minus 2m, 1 is the 0 of the root of the 5, 4m is equal to 0, then m is equal to m plus 1 is the factor of 5, 4m. So now the procedure to apply Hardy method. First step is write the coefficient of the polynomial in decreasing power. Coefficient, write the polynomial this in decreasing power. High degree term and lower, 4, 3, 2, 1. If the any term is missing, means in polynomial is incomplete in m, so complete it by putting 0 into that variable. So complete the polynomial. Fourth term is here, multiply minus 1. 0, if you multiply equation by any multiply equation, divide any equation by any number, roots of equation remain unchanged. So you go multiply minus 1, 0. So now fourth degree, third degree, second term missing, put 0 m square like this. Now write write the coefficient descending power of this. Write the coefficient descending power. If you divide 5, 4m by m is equal to 1 is the 0 was 0 is equal to m minus 1 is factor of this. If you divide 5, 4m by m minus 1, we got remainder is equal to 0 and this is remainder 0 and quotient is the quotient point. This comes out to be 5, 4, 5, 3m minus 5, 2m minus 5m minus plus 1 quotient. So m is equal to m minus 1 is factor, so m is equal to 1 is 0. M is equal to 1 divided by m. Put m is equal to 1 factor, m is equal to m minus 1 factor, put m is equal to 0, m is equal to 1. So divide this 1. Coefficients. Write first coefficient. Write the coefficient descending power. Write first coefficient is multiply this way. 1 into 1, 1. Add them. At first coefficient is minus 1. Multiply 1 minus 1, minus 1. Add them, minus 1. Multiply 1 minus 1, minus 1. Add them, 1. Multiply 1 with this 1, 1, 1 to 0, 1 to 0. So it's possible. Now this polynomial 5, 4x can be written as this into x minus 1. So now minus 1 was also 0 of this again. So again, we divide the quotient by minus 1. Minus 1, minus 1. First quotient is it is minus 1 into 1, minus 1. Minus 2, minus 2. Minus 2 into 1, minus 2. 2 to 2, minus 2 plus 1, 1. 1 into 1 minus 1, minus 1. Minus 1 plus 1, 0. Immediately 0. Now, again, we can solve it here also. Now, we can write 5 for m. If you want to solve it from here, we can write 5 for m is equal to m minus 1 into m plus 1 into, this will be equal to how much? This how much? This is equal to this how much? This is m minus 2m plus 1, m square minus 2m plus 1 is equal to this effect, this effect is of this. So this was 0. So m comes out to m is equal to, from this we got m is equal to 1, 1, this factor, and this factor m is equal to minus 1. Now other roots will be given by m. This will, how many can add? M into m minus 1 whole square is equal to 0. M is equal to 1 and 1. That is 1, 1. So now this equation, this 5 4 m 5 4 m have 4 roots, minus 1 and 1 is repeated 3 times. So root of the polynomial 5 4 m is 0 or 0 of the polynomial 5 4 m. Now if these are the zeros of 5 4 m, then these will be m is my plus 1. Take this left hand side, m minus 1 factor of this, m plus 1, m minus 1, m minus 1 factor of factors of 5 4 m. So if we can find 5 for m, if we multiply this vector by the leading coefficient, we got the same 5 for m. Leading coefficient into, we know we have read in the quadratic equation this. Leading factor to each factor will give us the same polynomial. Right? Now our aim is to find the asymptote, the y-intercept for these values. Now minus 1 is repeated one times, and when repeated one time, so the y-intercept for this will be c variable. For this, y is equal to m is equal to minus 1 will be given by c is equal to minus 5 3m. In the case of cubic polynomial, it was 5 2m upon minus 5 2 upon 5 3 dash m. But in case of the by quadratic polynomial, c will be equal to minus 5 3m upon 5 4 dash m. Put m is equal to minus 1 and substitute the 5 3m and 5 4m from here, and put m is equal to minus 1. We got c is minus 2 by 3. The corresponding the asymptote will be, substitute the value 2 by 3 and we by y minus 1 minus 2 by 3. Simplify that, we got this one. Right? Now find the derivative. 5 4m is this, 5 4m dash is this, 5 double dash is this, 5 triple dash is this. 5 3m is this, the fourth degree term, third degree term, the derivative this term, second derivative this way, 5 2m, second term of 5 second degree term of f of x y when m is equal to 1, x f is equal to 1 and y is equal to 1. Definition of this and cover. Now m is repeated, the slope m is repeated 3 times. The value of the y-intercept will be given by the equation c square by 3 factorial 5 4 5 4 third derivative of m plus c square by 2 factorial 5 3m second order derivative plus c into 5 2m first order derivative plus 5 1 into 0. Now put m is equal to 1, put the value of 5 3m, 5 4m, 5 4m from here, and c square by 3 factorial, 5 4m from here, 5 4m third derivative from here, 5 3m second derivative from here, and 5 2m second derivative from here, and 5 1m is from here, and substitute the value m is equal to 1 in these equations, and we'll get a cubic equation for c. For the value of c, factorize that, c comes out to 0, and c, this is quadratic remaining, quadratic from quadratic, we got the two slopes, we got three slopes, three intercepts for the three slopes, so we'll get three asymptotes y is equal to x plus 0, y is equal to x minus 1, y is equal to x minus half. fourth asymptote for the 4 degree asymptotic curve